Hi guys, welcome back to the channel. I made good progress. I got a ADC up and running. Like I said yesterday, I had a model which is synthesizable and the actual hardware interface, and I have a switch on the board that I can select take samples from the model, or which is kind of internally generated, or take samples from the actual ADC. So yesterday I wasn't aiming actually to connect the real ADC. I discovered I have a development board, and I had to hack a little bit. Probably I spent more time hacking the board than working on the actual design. I had to disable some of the regulators on the board because they were conflicting with my regulators. Now this ADC is making its sampling positive value, so the signal should be from ground to VREF, so it's positive. That's why it has to be biased halfway, midway, let's say. So there is a regulator on the board which is creating, it's actually a reference, which is creating a 2.048 volt, and then it's divided by two resistors and is biasing. I'll show you the schematics in a second. But anyway, I had to get that properly working. Now I applied a signal from a test generator. So I have like a lab test generator here, not great but good enough. So I'm applying different frequencies and I can see them there, and I'm capturing everything like I said yesterday. I'm capturing everything with the ILA, with the integrated logic analyzer. So you can actually see the samples, and I changed the frequencies, and yeah, it seems to work fine. I mean, it just worked out of the box. I didn't add much to the VHDL other than probably the ILA core and the selector for the model or the real samples from the ADC. It seems to work fine. I'm very, very happy. Now, I'm going to show you in the demo that I can confirm that we don't need an external mixer. And how I confirm that? So our sampling rate is 4 megahertz or 4 mega samples per second. Right? So my first test obviously was to apply something in the band, like the amateur band is going to be 200 kilohertz wide or 400 kilohertz wide, depending on the band I choose. But anyway, it's in the hundreds of kilohertz. So I apply a 200 kilohertz signal from the test pattern generator. It looks great. Then I switch to the internal model, which is 250 kilohertz. Looks fantastic, of course. And then to actually confirm that I can undersample, I put a signal from the pattern generator which is 8.1 megahertz, so 100 kilohertz above 8, and that should alias back into the Nyquist band to show like 100 kilohertz signal. So 8.1 megahertz sample with 4, it will translate back into 100 kilohertz signal, and it's sampled and it looks fantastic. So now I know that is going to work. Of course, I need filtering and I need a bunch of other things, but it proves that it works. I mean, I was expecting that it's going to work. Now, for this arrangement to work, there are a few conditions. Your signal has to be band limited. Of course, it's band limited here in our case because it's a signal generator, so it's just one tone. And you need to make sure that your band fits in the Nyquist band. First condition. Second condition, your ADC has to be fast enough so the full power bandwidth of your ADC should take this high frequency signal, which is going to be down sampled. So it's going to pass this signal actually. So yeah, I'm going to go straight to the demo. I'll try to put a picture. I'll show you the screen how I'm capturing with ILA via JTAG. And I'm going to put a camera on top of the board and the generator so you see what I'm doing. Okay, so what's the setup here? We have the board. This is the LTC board. Now it has a bunch of other things there which I don't care about. Regulator, it has a CPLD here to be interfaced with some other board from Linear Technology. Now our part of interest is actually this one, this tiny little fella here, which is surrounded by the white rectangle. We have 3 wires, which is chip select, clock and data coming to our board, and of course ground and power supply for the board. And that goes in here on a P mode. There are basically 3 wires plus ground. That's all. Now I have a blink there just to prove that's a proof of life. And I have here a selector where I can select the samples to actually be sampled from the interface or sampled from the internal core. Now what we have here, the board, it takes signal. Let me put the camera. It takes signal via this BNC from a signal generator, which is this fantastic signal generator. And right now I'm applying, what I'm applying there, I think that's a 100 kilohertz. It's a very funny way to display the frequency there. Anyway, I think who made the user interface. Now it's a lot of shit here on my desk, so please ignore that. Okay, so I'm going to keep the camera on top of the signal generator, and I'll show you how I'm capturing the actual signal. Okay guys, so what we have on the screen now, it's this is the ILA, so I'm going to trigger the ILA. Bang. Bang, it didn't work, sorry, I was clicking on the wrong screen. And this is our signal from the generator, so I'm going to modify the frequency, make it lower, let's say. So frequency, how do I do that? Like this, let's make it 30 kilohertz, right? So now we sample again. Yeah, it is slower. Just zoom out a little bit. Now I'll go faster. I'll go the frequency up, like let's say 250 kilohertz, and sample again. Okay, obviously faster. I'll go even faster, like 400. Go again. Yeah, so definitely working. Now, if I have a switch here on the board, now I'm going to switch. You won't see it, but you have to believe me. So now I switch to the internal generator or the model. So when I sample again, bang, this is a 250. So I switch back now to the signal generator, I mean the lab signal generator, and bang, is done. Now I'm going to change, like I said, I'm going to put this frequency. So let's put here 100 kilohertz. I hope it's visible on the camera. So this is 100, and I'm going here on the megahertz to what? To, let's say, 20.1 megahertz, right? So let's sample this. You see, it looks like 100 kilohertz. If you don't believe me, I'm going to make it 100 kilohertz. So just remember that screen. Now I'm going to make it 100. And I'm going to sample again. Yeah, looks kind of... Now, you can see the amplitude is a little bit different because I think my signal generator, it's not... I think it's losing a little bit the amplitude, or it might be the circuitry that, the cables and things, they affect a little bit the amplitude. That's why when you see here the amplitude, which is captured when it's a real 200 kilohertz or 100 kilohertz, sorry, or I go here like 20.1 megahertz, the amplitude is a little bit lower because of the attenuation across cables and things, but that's not a problem because we will have a VGA, a variable gain amplifier in front, so I think we are going to be fine. So yeah, this seems to work fine. I mean, I'm kind of happy. So look, if I cut the output completely, so we have no output now. We should see noise, or I don't know. Probably we'll see the middle, the bias in the middle. Yes. So this is the bias, because I said the input actually is biased to 1 volt or 2.048 volt divided by 2. What's that? It's a 1.024 volt. So it seems to be fine. I mean, I don't see any noise there. No, not that I can read on such a small screen. Okay, so what I'm planning to do next, first of all, my samples which are coming from this, they're all positive. So I probably, the first thing to do is translate them into two's complement, like sine samples. Maybe the next thing to do is to try to make a simple AM demodulator, because my signal generator is actually capable of putting out a modulated signal, and just make a quick test on the speaker to see if I can demodulate. I'm not sure. This sounds like a big step forward. I'm not sure now if I should do this right now, or I should just clean up a few things. Now, I'm not going to make PCBs anytime soon, because I think I can get away with this development board for a while. So I'm not going to jump straight to making PCBs and things like that. Yeah, this is it. ADC, I think it's sorted. I'm thinking what to do next, and I'll let you know probably tomorrow, after tomorrow, soon anyway. Thanks for watching, and stay close.